Solar panel degradation adjusts from 0.4% to 0.35%. What impact does it have on power generation?
Do not underestimate this 0.05% difference. A power station can generate 0.6% more electricity per year. Let me calculate for you. Look at this table. Take 620-watt solar panel for example. First year, accumulated degradation is 1%. Second year is 1.35%. 1% adds 0.35% annual degradation. Then let's look at the 25th year performance. Accumulated degradation is 9.4%. First year, 1%, add 0.35%, multiplied by 24 years is 9.4%. Decrease 58.28 after 25 years, and the actual power is 561.72. The annual average degradation is 5.2%. Take average of these values. The second table is based on 0.4% annual degradation. First year, accumulated degradation is 1%. Second year is 1%, adds 0.4%, is 1.4%. 25th year, the accumulated degradation is 10.6%. 1% at 0.4% multiplied by 24 years is 10.6%. After 25 years, decrease 65.72 watts, and the actual power is 554.28. Annual average degradation is 5.8%. Take average of these values. In the third table, I make a comparison. You can see here 5.8% minus 5.2% is 0.6%, which means a power station can generate 0.6% more electricity per year. Currently in the market, year 2 to 25 degradation of BC 2.0 modules like LONGi and ICO is 0.35%, and that of TOPCon modules like Jinko, GA, China, Canadian Solar is 0.4%. Then you may ask, what's the meaning of 0.6%? Taking 1 megawatt power station in China as an example, the average annual power generation can increase by 6,000 kilowatt-hour. Look at here. 1 megawatt is 1,000 kilowatt multiplied by 4 hours multiplied by 250 days multiplied by 0.6% is 6,000 kilowatt hours. For us, let's do more power station calculations.